So in this video, I'm going to be going over questions 21 through 40 on the Unit 1 study guide. So for 21, the directions are to factor completely, okay. So question 21, they want us to factor 9v to the 6th, w to the 3rd, plus 33v to the 4th, w to the 5th. Okay, so for step 1, we're going to look for the greatest common factor between these two terms. So I'm going to start with the 9 and the 33. They both have a factor of 3. So I know I can divide out a factor of 3. They also both have at least 4 v's. There's 6 in the first term, 4 in the second. I'll just collect all the factors that I can. And they have at least 3 w's as factors. So I can factor out 3 w's from each. So once I divide those greatest common factors out, I see what's left. 9 divided by 3 is 3. V to the 6th divided by v to the 4th is v to the 2nd. W to the 3rd over w to the 3rd is just 1. So we don't have to write that because that would not change the value. In the second term, I have 33 divided by 3, which is 11. V to the 4th divided by v to the 4th, again, just 1. And w to the 5th divided by w to the 3rd, which is w squared. So once I am here, I've factored out the greatest common factor from each, and I look, can I factor what's in the parentheses still any further? And so there's not a difference of squares, there's no other like terms, there's no more like terms, that is correct, and there are no more greatest common factors that we can pull out. So that's as much as we can factor. We have the greatest common factor here, and then a factor of 3v squared plus 11w squared. Number 22, m squared minus 4m minus 32. So again, I look for the greatest common factor. I see that there is none except for 1. But if I factor out a 1, similar to 21, I end up with the same problem to solve. So I'm going to factor this using the area model. So I know that each of these spaces are going to add up to everything in my original expression. So there's the area that is m squared. Then we have this area is negative 32. And this negative 4m is going to come from the sum of these two spaces. So I'm just going to do some side work. Negative 4m is what these two terms add up to. And they multiply to what these two terms multiply, which is negative 32m squared. So I list out all my numbers that multiply to 32. I'm going to hold off on which one's negative, because one of them has to be negative in order for them to multiply to a negative 32, right? But I'm going to just look at what makes 32. 1 and 32, 2 and 16, 3 and nothing. 3 actually doesn't work. So I move on to 4. 4 and 8. And then 5 does not work, 6 does not work, 7 doesn't work, and then I would just start repeating. So once I have all these factors out, I just look at, well, which ones added together would be negative. But again, I have to make one of these negative in order for it to be negative 32. So I know that there's supposed to be a difference of 4. So I look for the ones that are separated by 4. That would be 4 and 8. And which one would have to be negative to add to negative 4? That would be 8. So negative 8 times 4 is negative 32. And 4 plus negative 8 is negative 4. So we have negative 8m and a positive 4m. That's where the negative 4m came from, right here. And now I pull out the greatest common factor. From each. And then I write out my expression as base times height. So here's the base. And there's the height. There's my factored form for the original polynomial. 23. Similar problem. D squared plus 21d minus 72. I set up my area model. D squared, negative 72. So I know these terms add to 21d, but multiply to negative 72 d squared. Again, I start listing out the different terms, or the different pairs of numbers that multiply to 72. And then I stop once I see these two have a difference of 21. Right? One of them has to be negative to multiply to a negative. It has to be the 3. Because negative 3 plus 24 is 21. So, 3, 24. These numbers go in our missing space to make up that 21d. Okay. So again, you could switch these if you wanted, but we're just going to factor out the terms this way. Right? So if you switched it, you would just kind of be rotating your area model. But greatest common factor, greatest common factor, greatest common factor, greatest common factor. So your answer is d minus 3 times d plus 24. And we have number 24. W squared plus 19w plus 60. Again, I use my area model. W squared. 60 goes in the bottom corner. So I have my multiplying term, 60w squared. I know these two spaces have to add up to this remaining portion, 19w. And now I need two numbers that multiply to w squared and add to 19w. Start listing them out. And I stop when there's some that have a difference, or it can add to 19. Oh, 4 and 5. 4w and 15w add to 19w, and they multiply to 60w squared. So those are how I split up the 19w, 15 and 4. Factor out the greatest common factor for each of the rows and columns. I write out my base times my height, base, height, and this is my factored form. So 25, we have x squared plus 16x plus 63. I set up my area model. The x squared term goes in one of the corners. Diagonal from it is the term without a variable. I know that these two boxes have to add to 16x. They have to multiply to 63x squared. I list out my factors. 1 and 63, 2 does not work, 3 and 21. 4 does not work, 5 does not work, 6 does not work, 7 times 9 is 63, 8 does not work, and then I would just start repeating. So I choose the two that add to 16. So I have 7x and 9x. Those are the numbers that I fill in my area model spaces with. And then I'm going to factor out greatest common factor. Greatest common factor of these two is x. Greatest common factor of these top two is x. The greatest common factor of these bottom two is a positive 7. So then my answer is x plus 9 times x plus 7, base times height. We have 26, 4n squared plus 62n minus 32. So this entire time I've been kind of mentally checking if these have a greatest common factor. They never did. They always had a factor of 1. So I was just instantly going here. You could do that same process with here. You just go straight back into the area model with these numbers. But you'll end up with needing to factor out the greatest common factor at the end. So to avoid doing that, I'm just going to factor out the greatest common factor first. So I look at the 4, 62, and negative 32, and notice that they all have a factor of 2. Right, so I divide each of those terms by the greatest common factor, because I am dividing it out, and I end up with 2n squared plus 31n minus 16. So now I look inside these parentheses and say, can I factor that any further? So let's see. The 2n squared would go in one of my areas in my area model. Then we have the negative 16, because that minus. And then we check to see how we split up that 31n. So adds the 31n and multiplies. So now 2 times negative 16, which is negative 32. And then there is an n squared. Okay. So I need two numbers that multiply to negative 32, add to 31. Let's go 1 and 32. 2 and 16. 4 and 8. And 5 does not work. 6 does not work. 7 doesn't work. And we would just be repeating after that. So these are all the ones that add to 32. One of them has to be negative in order for it to be negative 32. But they also have to both add to 31n. So I look to see which ones do that. It would have to be 1 and 32, where 1 is negative. So I have negative n, negative 1n, and a positive 32n. 32n, negative n. Pull out greatest common factors. Negative 1. For these two, it is positive 16. For these two, it is a positive n. And for these top two, it is 2n. I write out my base and my height. Base times height. That is my completely factored. Oh, sorry. So this is what's factored inside the parentheses, but we had that 2 on the outside from before. Can't forget that 2. I almost forgot it. So it should be 2 times n plus 16 times 2n minus 1. That is your completely factored answer. Seven. 5z squared minus 17z plus 14. So I look, is there any greatest common factor? Not besides 1. And there's only a 5, 17 doesn't factor at all. There's only a 2 and a 7 and a 1. So there's only 1. They don't all have z's, so I can't do anything with it. So I just have to factor with what they gave me. So the 5z squared goes there. 14 diagonal from it. Right, so now my 2 missing spaces to add to negative 17z. And then they multiply to 5 times 14 is 70. And then it is z squared. Right, so I list out all my terms. 1 times 70, then multiply to 70. 1 times 70, 2 times 35. 3 does not work. 4 does not work. 5 works, so we have 5 times 14. And then we have 6 does not work. 7 and 10. 8 does not work. 9 does not work, and then we just start repeating. So we need to use some combination of these terms to multiply to 70. Any of them do that, but they have to add to negative 17. So 2 positives can never make a negative. We can never add those together to make a negative. But 2 negatives can. Okay, so you could make all of these, but the combination we need is 7 and 10 make 17, negative 7 and 10 add together to be negative 17. So we have negative 7z, and we have negative 10z. That's how So when there is these double negatives and this number is positive, the negatives can be kind of tricky, so you just have to make sure that all of these spaces end up having terms that will multiply into them correctly. So this is what I mean. So if we factor out the greatest common factor here, it is 7. Greatest common factor here, it is 2. Greatest common factor here, it is just z. And the greatest common factor here is 5z. See, now if all of these are positive, there's no way that we can multiply to get in these negatives. But we know that that's what we need, because that's what was given. So something has to be negative. Right? So if I make this negative 7, then z times negative 7 is negative 7z. But negative 7 times 2 is not positive 14. It would be negative 14. But if we look here, we have 5z times 2 does not equal negative 10. So this 2 must also be negative. And then our 14 would work out. Negative 7 times negative 2 is positive 14. And then we also get these answers, which we needed to. So that's just an extra step to make sure that everything you are factoring out using the greatest common factor does actually multiply in to give you the values that we know to be true. But we still just write base times height after we take care of that. So we have 5z minus 7, and then z minus 2, base times height. We have number 28, that is 2w squared plus 13w plus 15. Look for any greatest common factors. There's just one, just the number 1, so we have to deal with it the way it is. That's okay. Put 2w squared, 15 goes diagonal. We are adding to 13w, multiplying to 30w squared. Right, so you can list out all the factors of 30 and see which ones multiply to, or add to 13. But it is 3w and 10w. So that's what goes in these empty spaces in our area model. Factor out greatest common factor. This bottom two, it is 5. These right two, it is 3. These left two, it is 2 and a y. And these top two, it is just a y. So write our answer: base times height, 2w plus 3, w plus 5. There's our factored answer. So a few more of these straight factoring ones. We have number 29. 4a squared minus 25. So this is a difference of squares problem. The way that we check that is that we see, well, this first term, well, you can look for the greatest common factor and realize that it's 1. But after that, there is no middle adding term. But this term right here, this first one, 4a squared, that is a perfect square. This 25 by itself is also a perfect square. And we are subtracting the two perfect squares. So that is the difference of the two perfect squares, difference of squares. So once we figure that out, we can just take the square root of the first term, which is 2 and an a. 2 and an a. And then we have the square root of the second term, which is just 5. And we have subtraction and addition, minus plus, or plus and minus. You can flip. You can have this term first or this term first. Both work. Essentially flip them. But this ends up being our answer. We're going to recognize this is a perfect square. This is a perfect square. And we have the difference in subtraction. So square root of the first term is 5x. Square root of the second term is 12. Plus and minus. And that's what I mean by you can kind of just push them as long as there's 1 and 1. So we look for the greatest common factor. There is none besides 1, so we just have to deal with the problem the way that it is. We bring out the area model. 7c squared minus 9. These two empty spaces have to add to negative 2c. And they have to multiply to negative 63c squared. So we have 163 2 does not work. 3 does work, 3 and 21. 4 does not work, 5 does not work, 6 doesn't work, 7 does work, these are 7 and 9, 8 doesn't work, and then we just be repeating. So one of these has to be negative in order for it to multiply to negative 63c squared. But they also have to add to a negative 2c. So there has to be a difference of 2 between them, which would be the 7 and the 9. And the 9 has to be negative in order for them to add to 2c, or negative 2c. So we have 7c and 9c. Sorry, negative 9. Negative 9. Greatest common factor of negative 9c and negative 9 is negative 9. Greatest common factor of 7c squared and 7c is 7c. Greatest common factor of these top two is just the c. And the greatest common factor of these two is just the positive 1. So again, we do base times height. So our base is 7c minus 9 times our height, which is c plus 1. Like that. So for this next problem, I'm going to get a new piece of paper. I don't want to cram it in that small space. But number 32, right here, says select an expression that is equivalent to the following. Hint, think greatest common factor. And then it has this expression. So let me write it down. We have number 32. X plus 3 squared minus x minus 6 times x plus 3. So the first thing that I want to do is I'm going to take the hint and say greatest common factor. Maybe I don't see it right away. So I'm going to expand this out so that I'm seeing everything completely expanded. So then I look, what's the greatest common factor of these two terms? Here is my first term, and here is my second term. And they're being subtracted from each other. So here I notice, well, there is an x plus 3. Here there is also an x plus 3. So I can factor out that entire thing, x plus 3. So that means that I'm going to divide out an x plus 3 from this first term, this first group, and an x plus 3 from the second group. Two of those just cancel each other out, like that, and these cancel each other out. So I pulled out, or I divided out, an x plus 3 from this first term, and what was left was x plus 3. Because there was originally 2 of them. Now there's just 1. Minus, from the second term, once I factored out this x plus 3, all I was left was the x minus 6. So I look back at number 32. Are any of them like this? So yes, C is. That's exactly what C is. Right? So this says an expression, meaning that there was only one answer. But you could even look at these other ones and say, well, this can't be the answer because it's missing this factor of x plus 3 on the outside. This term right here is missing both the minus x minus 3 and this x plus 3 on the outside, right? Something just completely disappeared. Well, is that true? So I might have rushed into that, but let's check, right? Sometimes that happens. Can this simplify or can this simplify at all? Well, these are not like terms, so we can't really do anything with that. But in here, we have an x term minus another x term. So those cancel each other out. What I mean is we have x minus x, right? X minus x, and we have positive 3 minus a negative 6, which is a positive 6. So if I simplify this more, these two cancel each other out. They zero each other out. So the x plus 3. And then 3 plus 6 is 9. That's being multiplied. So this is actually a lot closer than I thought, but it's still incorrect because this should be a 9, not a 3. And then here, this one's totally off because we know that it should be 9 x plus 3. So this should not even be here either, right? Because there's no other term involved in this factoring. So the only correct answer is C for this original process. Okay. Number 33 says to write an equivalent expression, or write an expression equivalent to the following after you factor out the GCF. So we're going to do the same process, but we're going to factor out the GCF for this problem. So I rewrite the problem: x minus 5 squared minus x plus 2 times x minus 5. So I expand this first term, x minus 5 times x minus 5, minus from that minus right there, x plus 2 times x minus 5. I have these two whole terms. They have a common factor of x minus 5, so I factor that out. So I have factored out the x minus 5, and I rewrite what is remaining. So those two cancel each other out. I'm left with 1x minus 5 minus these and these cancel out. So I'm left with just an x plus 2. So all they wanted was an expression equivalent to this after you factor out the GCF. So instead of doing everything I did on 32 to kind of be checking these other ones, I'm just leave it like that because this is equivalent with the greatest common factor factored out. So that is my answer. I don't need to do anything more. So number 34, we have find the number that goes in the box to create an equation that is true. So they give us this equation. So we have 3 times 5x plus 2 times 4x plus 1. And there is a missing number, the coefficient of x squared, the number out in front. We have 39x plus, and then we have another missing number. So we have to figure out what these two numbers are. So the way we're going to do that is that we're going to multiply all this out. Right? So if we completely simplify or multiply all these terms out, we should end up with something right here, but we'll know what those two numbers are, and we'll be able to fill in the box. So rather than putting the 3 in first, I'm actually going to multiply these first two. So I have my base of 5x plus 2 and my height of 4x plus 1. And I figure out what's inside each of the boxes, each of the area models. So then I have 5 times 4 is 20. X times x is x squared. I have positive 2 times positive 4x. That is 8x. I then have 1 times 5x. That is just 5x. And 2 times 1, which is just 2. So then I add up all this area together to see if I can combine any like terms. So that leads me to 20x squared plus 8x plus 5x plus 2. I just listed all of them out and realized that there are 2 like terms, those 2. 20x squared plus 13x plus 2. So that is these 2 numbers we multiplied. But now I still had that 3 out in front times all of this. And I can distribute that 3 to each of the terms, multiplying each term by 3. So then I end up with 60x squared plus 39x plus 6. So I multiplied these 2 together, got my answer, and then multiplied the 3 into each of them. So this box should be 60. And this last box is just the 6. So 35 is very similar. We have 2 times 3x minus 1 times 2x plus 7. We still are missing the coefficient on the x squared, but now we're missing the coefficient on the x as well. But we have the negative 14. Again, I'm going to multiply these out. Here's my base, here's my height. I'll take those 2 first. So I have 3x minus 1, 2x plus 7. Here I have 2 times 3 is 6, x times x is x squared. Negative 1 times 2x is negative 2x. 3x times positive 7 is 21x. Negative 1 times 7 is negative 7. So that is everything in, or when I multiplied these 2 together. So I have 2 times 6x squared. And then I have negative 2x plus a positive 21x, so that is a positive 19x in total. And then I have the negative 7. I can then distribute that 2. So then I end up with 12x squared plus 38x minus 14. Right, so I have the negative 14 right there. This is 12. And this is 38. $36. So 36 is a word problem. And it says a square has the side length of 4x minus 3 centimeters. So I'm going to stop there and say, okay, number 36, there's a square. Right. It's an okay square. Right. So it has a side length of 4x minus 3. And that's in centimeters. So since this is a square, we know that, well, one, it has right angles. but more importantly, that all of these sides are the same, right? That's a property of squares. Every single side in a square is the same length. So if this is that length, this height is the same thing. Okay, so why do we care? Because they asked, what is the area of the square? Well, area for a square is the base times the height, right? So now we have a base and we have a height. Right? So we have base times the height. But if we just looked at this square this way, 4x minus 3, and this height is 4x minus 3, we just have our area model. This is just the area model for this problem. Right? So we treat it the same way. We have 16x squared, 4x times 4x. Negative 3 times 4x is negative 12x. Negative 3 times negative 3 is positive 9. Negative 3 times positive 4x is a negative 12x. And then we just combine like terms, add all this together. So that gives us 16x squared minus a total of 24x's plus a positive 9. That is our area. Well, and they gave us centimeters, so technically this is in centimeters squared, because it's centimeters times centimeters. But that would be the unit. And this is in the form ax squared plus bx plus c. That they're just saying to simplify this. So I have ax plus bx plus c. So 37 works in a very similar fashion, except now we have a rectangle. We don't have a square. Right? So we still have right angles, but not all the side lengths are going to be the same. They don't have to be in a rectangle. But they give us the side lengths as 3x minus 1. And then another side length is 4x plus 3. Right? And then you can see it's still just an area model. Because we're just want to find for 37, we want to find the area of the rectangle. So 3 times 4 is 12. X times x is x squared. Negative 1 times 4x is negative 4x. Negative 1 times positive 3 is negative 3. And then 3x times positive 3 is 9x. Again, combine like terms. Add everything together, 12x squared. Negative 4x plus a positive 9x is a total of positive 5x. And we have this negative 3. Right? And then they didn't give us units this time, but it would be whatever units squared. Right? This way it was centimeters because they gave us centimeters, but we know the units will be squared. So that is the answer. 12x squared plus 5x minus 3 units squared. So now we have number 38. So I'm going to come over here and might need to zoom out a bit for this one. So number 38 asks us to identify the first step in which an error occurred and the correct answer Oh, and correct the answer for that step. Okay, so what they're asking for here is that they have these series of 6 steps. They've numbered them off on the left side, and then they give you the work on the right. So at some point, a mistake was made. So what we have to do is we have to go step by step and see where was the mistake. Right? So the original problem is x minus 5 times x plus 1 times x minus 2 squared. Okay. So then we see what they did. What did they do in the first step? Well, this x minus 2 squared was the same, right? So there's no error there, they just moved it down. But it seems like they multiplied these two together, right? So let's see. It looks like they distributed, because right, they end up with 4 terms right there. They didn't use an area model. So let's copy them and see what we get. So we have x times x is x squared. Then we have x times 1 is positive x. Negative 5 times x is negative 5x. And we have negative 5 times positive 1, which is negative 5. Then we still have that x minus 2 squared. So then we look. Well, x squared plus x minus 5x minus 5 times x plus 2. Okay, so no error there. Right, so they did step 1 correct. Right, so let's look at what they did for step 2. So they ended up with 3 terms here. So it looks like they just combined these two like terms. Okay, well, let's combine our like terms. So x squared, so x minus 5x should be negative 4x minus 5, and then we just rewrite everything else. Okay, so now we double check. So they have x squared, there it is. So they have a positive 4x when it should be negative, because there was more negatives from this negative 5. Right? So at which step did the error occur? That was step 2. And then our correction of the step is right here. So we should have had x squared minus 4x minus 5 times x minus 2 squared. And then after that, we don't need to worry about that, because this is all that they asked for. So we have number 39. So it's the same kind of problem where they want us to analyze each step that occurred and then correct whichever step there was an error on. So let me use a piece of paper, might be easier to see this way. So the original problem is x minus 1 times x minus 2 times x plus 1 squared. So let's see what they did here. So on this first step, again, it looks like they multiplied these two terms together. So let's multiply our first two terms. We distribute. So we have x times x. That is x squared. Right? And then we have then we have x times negative 2, which is negative 2x. Then we have negative 1 times x. That is negative 1x. And then negative 1 times negative 2, which is a positive 2. And then we still have this x plus 1 squared. All right. X squared minus 2x minus 1x plus 2, x plus 1 squared. So it looks like they did step 1 correct. Let's look at what they did on step 2. They went from 4 terms to 3 terms. This is all the same. So they combined those like terms, is what it looks like. Okay, let's combine our like terms. That's where they made the mistake last time. So we have a negative 2x minus another x. So that's a total of negative 3x plus 2. And then we have the x plus 1 squared. Right. So on step 2, they have x squared minus 3x, so they fixed that mistake, plus 1 or plus 2, and then times x plus 1 squared. Okay, so they didn't mess up on that step this time. What did they do after that? So it looks like this stayed the same, but this squared went away. So here's what I'm guessing what they did. So we kind of have to analyze, well, how did that happen? Right, so it looks like they tried to distribute that 2 as an exponent. That is not correct. You cannot just distribute that as an exponent. What you should do, if you're not sure what to do with this situation, is to just expand it